Alright, hey, this is Eros. I wanted to go over the data structures that the ERC token smart contracts use to keep track of balances and approvals and all that fun stuff. So there's lots of different ways you can implement the EIP standards for 20, 721, and 155, but I'm using Open Zeppelins because that's just the way to go. No sense in reinventing the wheel. So the first one we're going to take a look at is ERC20. Not too much going on here. Basically, just these three things here. That's all we got to focus on. So first is a mapping with the balances. So the owner's address and the owner's token balance. So user 1, 2, 3, and 4, and here are their respective balances. Simple as that. Allowances is what allows an operator to spend an owner's funds, or their tokens, on the owner's behalf. So in this example, user 1 has given 2, 3, and 4 certain amounts that they can spend. It doesn't matter that, for example, 10 plus 5 is more than user 1 has. The allowances doesn't care about that. Just like in this example, this is the max ERC256 value that he's allowed user 4 to have. You can do that. It doesn't matter that you'll never have even close to that amount. You're basically just whitelisting 4 to spend indefinitely of user 1's funds. And user 4 gives user 2 the ability to spend 10 of his 12 tokens. And this total supply is just in a ERC256, which, the total supply of ERC20 tokens in circulation. Okay, next one is the ERC721. All right, so these are the non-fungible tokens. So there's more going on here that we got to take a look at. First is a mapping from the token ID to the owner address. So we've got 3 NFT token IDs here, and these are the owners. So 2 owns this one, and user 1 owns this one. Next, a balances mapping specifies how many in this smart contract does this address own. In this case, they own 1, and user 2 owns 2, just like up here. Token approvals. So there's 2 ways to do approvals with NFTs. One of them is to whitelist just the specific token ID. So the owner of this one can say someone else can spend it. In this case, user 1, because he owns this one, gives user 2 permission to spend and send this token. Operator approvals. This is a nested mapping that basically allows, in this case, user 1 to give user 2 the ability to spend all of his tokens. So in this case, he only has 1. But if user 2 whitelisted 1 in the same way, user 1 could spend both of these on user 2's behalf. He does not give this permission to user 3, so it's false. And then, for any random address, it'll also be false. You wouldn't want random addresses spending your tokens. Next one we're going to look at is ERC721 Enumerable, which is an extension. So different data structures here because it has to keep track of different stuff. So a nested mapping from the owner to a list of owned token IDs. So the owner, and in this example, user 1 has minted 722 NFTs. And these are the token IDs. Oh, just an FYI. An actual token ID, because it's a ERC256, it's going to be some really large number, but I'm just trying to keep it simple. And then user 2 just mints these 2. The owned tokens index. So this just gives you an index of the token in the owner's list based on the token ID. So these first 2 belong to user 2 up here, and you can see 0 and 1. And this is the last one from user 1, correlates with the index there. Same thing with these first 3 here. This all tokens is an array list of token IDs, and it's going to be incremented to in the order that they're minted. So in this example, I'm assuming 2 minted them, some other people minted some, then 1 minted, 700 some of them. And that's what you'll see right here as well. So the all tokens index, this is how it keeps track of the index inside of these arrays. So user 2 minted these 2, so 0 and 1. 28 random other ones were generated by who knows who. And then user 1 minted 700 some. So the last one that has been minted has an index of 751. Next thing we're going to take a look at is the ERC1155 standard. So the multi-token standard, also known as a semi-fungible token. Really simple stuff for this one. Nested balances mapping and a nested approvals balancing. So balances, the token ID to the owner address, and then how much of them they have. And the reason we need this is because this token here could be fungible or non-fungible. In this case, 123456 is a fungible token. And so this is the token balance that each of these has of this token. This next one, however, is a non-fungible token, and so only user 1 has it. Operator approvals, similar to how the other approvals work, 1 gives 2 permission to spend all of his stuff, but not 3 and 4. The next one to look at is the ERC1155 Enumerable, which, looking in the Open Zeppelin repository as of right now, I don't see it here. They had older versions of it, so that's what we're going to take a look at. So right here, a lot to cover here. So first one, own tokens. So this is similar to the mapping we just looked at. So gives you the token index in the owner's list and then what that token ID is based on the owner. And the difference here, though, from this and the ERC721 enumerable is that some of these could be fungible, some could be non-fungible. So these two are fungible. The next 700 some are non-fungible. For user 2, first one's fungible, second one is non-fungible. For the current index, put in the owner, and then you'll get what basically however many they have. Well, the index anyways. So the last one he minted was 721. So that's what the current index is for user 1. Similar story for user 2. Okay, the own token index. This is where you can put in the owner and then the token ID that they own, and it'll give you where they are in the owner's list. So kind of like an inverse of the other one. ID total supply. So this is a new one. This is not in the ERC721 token because some of these are fungible. So owner and the specific token ID. And because these two are fungible, look at the balance. This is how many of those tokens owner 1 has. He only has 1 of 3 to 721 because all of these are non-fungible tokens, but these first 2 are fungible tokens. And again, most fungible tokens, most ERC20 tokens are going to have 18 decimals, meaning it's going to be some really high number. Well, probably without the plus, but I digress. I'm just trying to keep this simple. And then for user 2, fungible amount here, the non-fungible, so he only has 1. All tokens, just another array holding all of them, and then here's the index, but again, this is not tracked by the array itself, it's tracked in this mapping, the all tokens index. So in this scenario again, user 2 mints 2 tokens, although this one's fungible, and then 28 other things are generated or minted. Then user 1 mints 2 fungible token IDs and then 700 some non-fungible. And this all tokens index is what keeps track of this index here based on the token ID. So user 1's stuff here, and these are the indexes that come out.